If you enjoyed this podcast, please consider liking, sharing, and subscribing to the channel. Sharing it with your friends and family helps spread knowledge. And when we help others grow, we grow too. Thank you so much for listening. Let's dive into the podcast. Fritz Zwicky's question: missing mass in the Coma cluster, 1933. Picture Fritz Zwicky on a cold night in 1933, squinting through his telescope at distant galaxies. What he saw would shake astronomy to its core and leave us with questions we still cannot answer today. The galaxies in the Coma cluster were dancing, but they were dancing far too fast, like children on a playground spinning wildly without falling off. These massive star systems whirled through space at impossible speeds. According to everything scientists knew, they should have flown apart long ago. Zwicky did the math again and again. The numbers told a disturbing story. These galaxies moved as if held together by invisible chains. The stars and gas clouds he could see simply weren't heavy enough to create the gravity needed to keep everything in place. Something else was there. Something massive. Something completely hidden from view. He called it Dunkel Materie, dark matter. The name felt right for this phantom substance that refused to reveal itself. It was there, pulling and tugging at galaxies with invisible hands, yet it gave off no light at all. His fellow astronomers laughed. Some grew angry. How could most of the universe be made of something they couldn't see? It sounded like science fiction, not serious research. They had spent decades mapping the visible cosmos, cataloging every star and nebula they could find. Now this Swiss astronomer claimed they had missed most of reality itself. Zwicky stood his ground. The galaxies didn't lie. Their wild dance demanded an explanation, even if that explanation turned everything upside down. If the universe contained vast amounts of invisible matter, then humanity had been living with a blindfold on, seeing only tiny glimpses of what truly existed. Years passed. Other astronomers ignored his findings or dismissed them as calculation errors. But the question lingered like a whisper in the dark. What if Zwicky was right? What if the stars we see at night represent just a small fraction of what fills the space around us? The idea was both terrifying and wonderful. Terrifying because it meant our understanding of reality had enormous gaps. Wonderful because it suggested the universe held secrets far stranger and more magnificent than anyone had imagined. Today, nearly a century later, we know Zwicky saw something real that night. His invisible matter shapes galaxies across billions of light years. It bends starlight and holds cosmic structures together with its hidden gravity. Yet we still cannot touch it, catch it, or truly understand what it is. The dancing galaxies of the Coma cluster continue their ancient waltz, guided by forces we cannot see but cannot deny. The Rubin-Ford revelation. Unseen forces in galactic rotation, 1970. The year was 1970. Vera Rubin sat in the darkness of Kitt Peak Observatory, her eyes fixed on the green glow of her computer screen. The numbers staring back at her made no sense. Something was terribly wrong with the universe. For months, she and Kent Ford had been measuring how fast stars move around the edges of spiral galaxies. They expected to find what everyone knew should be there. Stars far from a galaxy center should crawl along slowly, like distant planets in our solar system. The farther out, the slower the dance. But the stars refused to follow the rules. Rubin watched the data pour in night after night. Stars at the very edge of the Andromeda Galaxy were racing around at impossible speeds. They should have been flung into the cold depths of space long ago. Yet, there they were, held in perfect formation by some invisible hand. The measurements were precise. Ford's new spectrograph could split starlight into rainbow patterns that revealed exactly how fast each star was moving. There was no room for error. The instruments didn't lie. Rubin traced her finger across the flat line on her graph. In a normal galaxy, this line should slope downward like a ski jump. Instead, it stayed level, defying everything scientists thought they knew about gravity and motion. She called these strange patterns flat rotation curves. The name sounded simple, but the implications were staggering. If the visible stars and gas in these galaxies were all that existed, the outer stars should be moving at half their observed speed. Something massive was out there. Something they couldn't see. Night after night, galaxy after galaxy, the same impossible pattern emerged. The Milky Way, Andromeda, dozens of spiral galaxies across the cosmic void, all of them held together by forces that shouldn't exist. Rubin's colleagues were skeptical. Perhaps the measurements were flawed. Maybe there was hidden gas or dim stars they had missed. But Rubin's work was flawless. Her maps of galactic motion were the most detailed ever created. The conclusion was inescapable. Most of each galaxy's mass was invisible. This dark matter, as scientists began calling it, outweighed all the visible stars and planets by a factor of 5 to 1. The discovery sent shockwaves through astronomy. If Rubin was right, then most of the universe was made of something completely unknown. Something that pulled on matter, but gave off no light. Something that shaped the cosmos from the shadows. The supernova surprise, accelerating expansion and dark energy. The year was 1998. Two teams of scientists were racing to answer what seemed like a simple question. They wanted to know how much the universe was slowing down as it expanded. Everyone knew it had to be slowing down. Gravity pulls everything together after all. The Supernova Cosmology Project and the High-Z Supernova Search Team had the same plan. They would study distant exploding stars called Type 1a supernovae. These stellar explosions burn with the same brightness every time, making them perfect cosmic lighthouses. By measuring how dim they appeared from Earth, scientists could tell exactly how far away they were. The team spent years collecting data. They tracked dozens of these exploding stars across vast distances. Each measurement brought them closer to the answer they expected to find. But something strange was happening in their calculations. The distant supernovae weren't behaving as predicted. They appeared dimmer than they should have been. Much dimmer. This could only mean one thing. The universe wasn't slowing down at all. It was speeding up. Both teams checked their work again and again. The numbers didn't lie. Somehow, the expansion of space itself was getting faster over time. This made no sense. What force could possibly push against gravity on such a massive scale? Scientists had to invent a name for this invisible force. They called it dark energy. But naming it didn't make it any less mysterious. This unknown energy seemed to fill empty space itself. It was everywhere, pushing the universe apart faster and faster. The discovery shook the scientific world. Meetings erupted in heated debates. Could there be errors in the measurements? Were the instruments wrong? Some scientists spent years trying to find flaws in the data. Yet more evidence kept pouring in. Other telescopes confirmed the same strange results. Studies of ancient light from the early universe showed the same pattern. Large surveys mapping millions of galaxies painted the same picture. The universe was roughly 70% dark energy. This invisible force dominated everything. It was more powerful than all the stars, planets, and galaxies combined. Yet no one knew what it actually was. This discovery changed everything we thought we knew about our cosmic home. The universe wasn't just filled with dark matter that we couldn't see. Now there was also dark energy that we couldn't understand. Together, these dark components made up 95% of everything that exists. What would happen next? Would this mysterious force tear the universe apart? The questions multiplied faster than anyone could answer them. Pursuit in the shadows, failed searches and unsolved puzzles, 2000s to 2020s. The machines hummed deep underground, their sensors waiting in perfect silence. Buried beneath mountains and sealed away from the world above, These detectors held a single purpose: to catch the ghost particles that scientists believed filled our universe. In 2008, the Large Hadron Collider roared to life beneath the Swiss countryside. This massive ring of metal and magnets stretched 17 miles around, smashing particles together at speeds that defied imagination. Scientists watched the collisions with hopeful eyes, searching for signs of dark matter hiding in the debris. Months passed, then years. The machines found many things: new particles, strange behaviors, hints of other mysteries. But dark matter remained invisible, slipping away like smoke through their fingers. Miles away, in underground laboratories, other experiments waited in the darkness. Xenon detectors sat perfectly still, filled with liquid that should have flickered when dark matter particles passed through. Lux sensors listened for the faintest whisper of collision. Each detector cost millions to build and years to perfect. The results came back empty. Again and again, nothing. High above Earth, space telescopes peered into the cosmic web, mapping the dance of galaxies across billions of years. The Planck Observatory captured the oldest light in the universe, searching for clues about dark energy's true nature. Every image revealed the same puzzle. Something was there, bending space and pushing galaxies apart, but it refused to show itself directly. Conference rooms filled with frustrated voices. Scientists who had spent their careers chasing these invisible forces began to wonder if they were chasing phantoms. Some suggested the experiments weren't sensitive enough yet. Others whispered that maybe the whole idea was wrong from the start. A small group of researchers spoke louder. They pointed to modified Newtonian dynamics, MOND for short, a different explanation that didn't need dark matter at all. What if gravity simply worked differently than Einstein thought? What if the missing mass was just missing understanding? The debates grew heated. Careers hung in the balance. Billions of dollars had been spent on experiments that found nothing. Young physicists wondered if they had chosen the right field. Older ones questioned decades of work. Meanwhile, new anomalies appeared in the data. Signals that didn't match predictions. Measurements that contradicted each other. The more scientists looked, the stranger the universe became. Today, the machines still run. Deep underground, sensors wait in the darkness. Space telescopes continue their watch. But after 20 years of searching, the greatest mystery remains unsolved. Dark matter and dark energy, if they exist at all, continue to hide in plain sight, leaving only questions in their wake. The debate grows. Unknown forces, new models, and the question of reality. 2020s. The decade brought whispers of something strange. Deep in observatories around the world, astronomers stared at their screens with growing unease. The numbers didn't match. Again. Dr. Sarah Chen rubbed her tired eyes as she studied the latest data from the Webb telescope. The distant galaxies seemed to mock everything she thought she knew. They spun too fast, moved in ways that made no sense. Something invisible was pulling strings in the cosmic dance, but what? Across the globe, her colleagues faced the same puzzle. The universe appeared to be mostly made of things no one could see or touch. Scientists called them dark matter and dark energy, but these were just fancy names for we have no idea. The mystery deepened with each new discovery. Some researchers began to wonder if Einstein himself had missed something crucial. Maybe gravity worked differently than anyone imagined. Perhaps space and time bent in ways no textbook described. Dr. Marcus Wem proposed that reality itself might be stretching and changing. He called it quintessence, a force that could grow stronger or weaker over billions of years. Others suggested that matter itself created gravity in ways that seemed impossible. The scientific community split into camps. Some held tight to dark matter, convinced that hidden particles danced around every star. Others threw out decades of accepted wisdom, arguing that the very laws of physics needed rewriting. Late-night conferences buzzed with heated arguments. Young scientists challenged their mentors. Old theories crumbled while new ones struggled to take root. Everyone agreed on one thing: most of the universe remained a complete mystery. The James Webb Telescope peered deeper into space than ever before. Each image raised more questions. Galaxies that shouldn't exist flickered in the cosmic darkness. Structures too big to form in the time since the universe began stretched across impossible distances. Computer models failed to predict what telescopes actually saw. The gap between theory and reality grew wider each month. Some scientists wondered if they were missing something fundamental about how the cosmos worked. Dr. Chen often walked outside after long nights of analysis. She would look up at the star-filled sky and feel a strange mix of wonder and frustration. Somewhere in that darkness, answers waited. But they remained stubbornly hidden, like secrets whispered in a language humanity had yet to learn. The greatest mystery of all loomed larger than ever. Was the universe truly filled with invisible matter and energy? Or had science taken a wrong turn somewhere, building elaborate theories on foundations of sand? The questions multiplied faster than the answers, leaving researchers standing at the edge of the unknown.